morning and welcome to this webinar brought to you by VTech Energy in Sweden. My hopes are that you're having such a beautiful morning as displayed on this picture of Stockholm, the capital of Sweden. My name is Johan Helén and I will be your webinar host for this event. I'm sitting here together with Johan Dylin, that is one of our system experts for the system NetSim. And today's topic is an introduction to NetSim, our grid simulation software. So we will give you a description and demo of the methods that we use behind the system, and also how you can create different scenarios when it comes to simulating your district heating or district cooling grid. If you have any questions, we welcome them during the webinar. You can type them into your GoToWebinar application that you will find in your right hand corner. If you click the tab questions, you can simply type in your question that you do have, and we will then address them in the end of the webinar. And this Q&A session in the end will contain as many questions as we can. If we have some questions that we can't answer right away, or we simply do not have the time for them for this webinar, we will get back to you by email or telephone. If you have questions after the webinar, or if you would like a personal demonstration of the system, feel free to contact us. You can do so at sales.energy@vtech.se. So a little bit of background about this company, VTech. So NetSim is developed and marketed by VTech Energy. We are a Scandinavian software supplier, and we have been on in this sector for about 30 years, and we have close to 500 employees and over 150 energy utilities as customers. And we always have the ambition to be the clear choice for companies in the district heating and cooling sector that are in need of some kind of accurate simulations for their existing or future grids. So what does a GSS, a grid simulation system like NetSim, do? We have some scenarios here. Of course, there are many more, and which ones that are applicable for your grid is completely dependent on in what scenario you are, if you are building a new grid or if you are trying to optimize a existing grid. But some scenarios could be placement and dimensioning of pumps. It could be dimensioning of new pipes, of course. You can also, with the system, quite easily unravel bottleneck pipes, so tight sectors in your grid. You can also do some kind of sectioning for the grid if you need to do so for a new construction site, for example. You can discover cold water stalls in the summertime. You can handle merging of grids if you have that scenario where you have many small grids that you need to merge into one big one. You can do some studies on the peak load, trying to, with dynamic simulation, see what is the time period that we have for different scenarios for the water to reach a certain temperature for a certain customer. And you can create many different types of customer supply feasibility studies, so you are absolutely sure that your grid can handle this new situation that you are planning on. So why do we need this grid simulation software NetSim? So NetSim will increase your knowledge about the grid, knowledge that maybe are completely tied to a consultant today. You will therefore decrease the number of consultancy hours that you need in order to make some simulations. You can lower your total energy usage in the grid, and the same goes for the pumping cost, basically because you can optimize the grid in a smoother way than before. You can predict the network behavior and therefore lower the maintenance cost as well. And of course, NetSim will improve your planning skills. So a good tool like NetSim will help you with the planning for replacing different pipes or building new ones. So how to get going with NetSim? We can offer trial periods of the system. This means that you will have access to the full software for a limited time with your own data. And it's quite simple, really. What we need in order to present this is some geographical information from the Geographical Information System, the GIS, and we also need some consumption data, and that's often from the billing system that we take there. Then we at VTech will do the rest in order to set up this model so you can then go and discover your own grid in NetSim. A quite simple system overview. We have a Oracle database, and into that we put, as I said before, the network data, the consumption data, and we also have some background information like maps in DWG or DXF files. All the information that you can supply is something that we would like to have a look at, and then we will see what is suitable for your grid in order to make this model of the situation here of the grid. So we have the database, and from the client computer where you have NetSim, you can maintain this model, you can build new pipes, you can change dimensions for old ones, you can change the pump settings, the production temperature, etc. Once you have a model that is suitable for this type of calculation that you would like to do, you send that data, the simulation data, into a simulation generator, and that will give you an output file with the result from this. And you will very easily see in the presentation that Johan makes a little bit later on what this looks like and how easy it really is to use NetSim in order to get a greater picture of what happens in your grid. Some of the users today, we have both district heating and district cooling grids. We have small and large utilities and corporations. So the customers really stretch from the very northern part of Norway down to Qatar, where we have one of the biggest cooling grids in the world. We have ready-made connections to a few grid information systems. So that's a quite easy way to implement this model from geographical information data that you have today. So with that said, I'm gonna leave the word to our system expert Johan, that will give you a short demonstration of what you can do in NetSim and how you can handle different scenarios. If you would like your own presentation, as I said before, that's something that we can give you, so please contact us at sales and we will help you with that. So with that said, I will leave the word to you, Johan. Welcome.
Thank you. So my name is Johan Dylin, and I'm working as a consultant at VTech Energy, mainly working with NetSim. And NetSim is the system you can see here, which I will show you a bit more of now. And to start with, you can see the blue lines, which are district heat network that we're working with today. And the rest is a background map. It doesn't have any function other than giving us a reference of where we are. And then this pipes, they are imported from a GIS system. You can import them from a GIS system of your choice, so you don't have to start drawing your net from the beginning in NetSim. But it's also possible to draw pipes manually if you want to. And it's mainly used when you're expanding or when you're trying new things in the net. So we can do something here, show you how to draw a pipe manually. We'll take the draw pipe option here, then just draw the pipe as we feel like. Get some prompts that we're going through. Here you can choose pipe type. So either choose a predefined pipe type that you have here, or choose a question mark to let NetSim dimension the pipe for you, which we will try here. So then we will create the pipe. The pipe automatically gets the length because you're drawing in a map, but you can also change the length if you know the predefined length of the pipe that you will use. And then apart from having a network imported from a GIS system, we also have power usage, and they are mainly taken from billing systems, which is also a billing system of your choice that we can import customer data from. And you can also manually create customers in NetSim, or only put the power usage straight to this node, which we will use now, and it's mainly used for dimensioning. So I will choose the node, put on power that we will use, and we'll also need to to put in a return temperature to make the calculations possible. So now we have a power and return temperature here. We'll save them, and those will then be used for the dimensioning here that we have chosen, the pipe. And now we can make a basic calculation of this net to see what will happen and see how we can view the results. Here we have some options. I will not go through them now, it's not really relevant, but yeah, you can choose how to make the dimensioning of the net if you want speed from speed of the flow of water, or if you want a specific pressure loss or similar. We will just start this here and run calculation. It goes fairly fast. Then we will go here and see if we can see any results. To start off, there is both charts and a map view in Analyze and tables. So you can get all the results in table form if you would like to have just numbers, but mainly for a good overview the map is used. And then, as you can see here, we have chosen temperature. We can give a bit of a smaller span here to allow us to see a bit more difference. As you can see, the colors are changing here. We can add a legend to see what the colors are, what they are showing us. So this is a temperature, with blue being the coldest is 95 degrees and red being the warmest is 98 degrees. So you can see that we are putting out 98 degrees here from the production plant, and it gets a bit colder as we go to the edges of the net. And we can also look at our pipe that we put here and see that it has a diameter given now. We use the question mark, so NetSim is now chosen from the predefined pipes that you have available. Yeah, give it a dimension for the criteria we have given it. There we can see a bit of that. We can also see, apart from temperature, we have a few different things here. Pressure difference is something that can be interesting to see. Here I have a bit fewer colors. You can choose the number of colors. I've chosen a bit fewer here to mainly show the green is the pressure that is okay and what we want it to be. But we also have the blue, which is a bit lower than what we would like it to be. We can change where the color changes. So we would like, this is in kilopascal, so we would like at least 150 kilopascal of pressure difference. And then we can see that we have some parts of the net here that have a bit lower pressure difference than what we would like. And also here we have a bit higher. And now we will see what we can do to make sure at least that we don't have too low pressure difference here. So we're going back to NetSim where we can change things, and we will try to add a pump to this. So you can add pumps to this system. I'll just give it a basic name, and then we can choose where we would like to have it. So we want it in this pipe, and I would like it to be in the supply. You can choose either supply or return, or you can choose to have it in both as well. But now I will use it in the supply line. And then we can either put a given head for it, but now I would like to see what kind of pump do we need to keep the differential pressure up in all parts of the net. So then I can do this. I can choose a set point. I will choose a node out here and choose it at the set point. And I want the differential pressure of at least, let's say, 200 kilopascal. And yeah, we need to choose which node here. So it is in the given pipe, but we need to choose in which end of the pipe it is as well. We'll save that. As you can see, we have a pump showing here. So then we will try to make a new calculation and see how that affects our results. run through the calculations again and open the results. If we take the pressure difference again, we can see that if we now lower this to 150 again, hopefully we will not have, we have one little pipe there. That's probably okay. But anyway, we have the area which we wanted to secure is now okay. We can also see how hard the pump is working to achieve this result. And it's giving us a head of 87 kilopascals, so it's not working very hard, but at least it's doing what we want it to. And this is something that you need to be aware of when you're using this pump. You should be at the dimensioning case, so usually the lowest temperature you're expecting to have in the net that we are working with. So make sure it's the coldest possible and the highest possible power usage in the net when you make a dimensioning of a pump. But that will give us an idea of what kind of pump will we need to achieve the results we want. And also we would see if the pump would affect, you can now see that we have very high pressures here that we didn't have before. So that's something to evaluate. Is that a problem for us, that the pressure is now higher here? And it's something that NetSim can show us. Where is the pressure now high? And are there any problems associated with putting this pump to ensure we get a high enough differential pressure down here? Something you can also do is make a route where if you want to see the pressure. So we want to make a route from our production facility until this point where we put the set point. Then we can check the charts to see how our pressure looks like. Something we can do here is choose pressure level to remove any height differences that are influencing this. So we can see that we have a supply line here with pressure losses. We have the pump giving us a higher pressure to ensure the pressure difference here is big enough. And on the other side we have the return temperature, which also have their pressure losses, but in the other direction since it's flowing backwards. So here you can see what are the pressures through the net. You can also show cavitation pressure to see if you have any risk of cavitation in your pipes. And we can see that we might have a risk here. It's not at the moment because this is the lower one is for the return line, and since it has lower temperature, it's not as high risk of cavitation. But it could be problematic depending on how sure we are about our return temperature in the area. Okay, and then NetSim can also do something else, which is using what we call dynamic simulations. So take time in as an aspect of what we're doing. We will try to see how that works as well. We'll close this. We will make basically the same calculation again, but we will do it for a given time period. And we will choose here dynamic. I prepared some time data, so we'll put in them. And this time data is showing what happens when our plant has some problem. So at 9 we will start having some problems, which means we're giving out a low temperature to the net that is lower than we want it to be. And we will use this calculation to see how it affects our customers and how long it takes for the water basically to travel through the net. So we will run this. We'll basically run the same calculation 16 times for 16 different time steps. So we're running through it here. Then we can open the results again, and it will look very much the same. And to show this, we will use the temperature. We now have a supply temperature of 95 degrees at the moment from here, but it will quickly go down to about 80 degrees and then stay there for an hour and then go back up again to the 95 degrees. What we can do is either we have the time steps here, we could just step between them to get a feeling of what happens, but we can also make an animation to see, give us a bit of a better view. So I will use this create animation. And now it saves all this data to give us an animation, but it's a bit hard to see what's happening now, so I will add a legend for it in the map over here. Okay, so now we have a legend to easier see what is the temperature and at what time things are happening. So we will create an animation. And now we can see the time steps moving here. And then we will take this animation to see it a bit slower and actually see what is happening. So you can see pretty quickly here that the temperature is going down from the production facility. It goes down, and at 10 it's down at 80 degrees. So then we will see how long it takes. You can see that this blue is getting out to the furthest edges here at around 11:30, so it's almost 2 hours of delay from when the production facility produces the cold temperature until it hits the customers furthest away. And this can be quite useful to get an idea of how the net works, what the delays are, how can you prevent this temperature actually getting to your customers. If you have multiple production facilities, you can maybe start some of them to reduce customer impact of problems that you have, or work out ways of how to avoid these problems. Okay, so that's the dynamic calculation. And about NetSim, you can see here that we have one production facility as shown, and there is no problem to add more of those. NetSim can handle all of them, and most nets have more than one, so it's nothing uncommon to have a lot of them. And you can add more. There's always one that will take up the difference in load, so most of the time you will have all the other production facilities set at a set production rate or power outlet, and then one of them will be controlling to make sure you have enough power to all the customers. You can also use accumulator tanks as the facility that regulates this. You can put in an accumulator tank that will provide hot water when to account for any differences in power throughout the day if you run these dynamic simulations. Okay, I think that's what I have to show you today.
So thank you very much for that presentation, Johan. We have a few questions that have come in the GoToWebinar application here, but it's not too late for you to ask questions if you have any. You can simply type them into your GoToWebinar application that you will find in your right-hand corner. So let's start with the first question here.